All right, ladies and gentlemen, welcome to the Salem State University Collins Observatory live stream, where we will be looking at the moon. And here it is. It is near first quarter moon, and it's a little out of focus at the moment, but let me work on that. There, that's a little better. And I'm going to just move it over a little bit. Whoa, here we go. So we're in video mode, and there's all sorts of wonderful quarters we can roam around to in real time. All right. I was hoping to be able to post the stream URL to my class, and as soon as I clicked go, I lost what the link was. So, hello, all right, people are here, wonderful. All right, wonderful, great to see you guys. Thanks for tuning in, and let's see, I don't think I can solve this URL problem, but if one of you can get the URL for this video and post it in the chat, then I can post it to the class website, and then we'll be good to go. All right, well, without further ado, let's look at the moon. Here we go. So I am new to live streaming from telescopes, so this software is something I'm still learning, so bear with me. But here we have the moon, and the colors look a little askew. It looks a little too bluish for my tastes, but I'm afraid to touch anything too sensitive. There's ways to move these bars around, but that could be trouble. Let me try and up the exposure time, see if we can get more light. Well, you can see that's too much. Letting in too much light, so 0.01 seconds, it refreshes every 0.01 seconds, and that seems to be enough of an opening to get the right amount of light in to see it. Okay. What we are looking at right now are a couple of mare, which are big basins that look dark, and when you look at the moon in the sky with your unaided eyeball, some people see a man in the moon, some people see a woman in the moon, but whatever you see, it's usually you're looking at these big dark patches on the moon and what shapes they make. And they are big basins. There's been some debate over the years about whether they were caused by meteor impacts or volcanic regions or both. And the pendulum seems to be swinging more towards volcanic regions on the moon. When the moon formed about 4 billion years ago, or give or take a few 100 million years, it was a big blob of molten rock, and as it pulled together into a ball and cooled, it didn't cool all at once, and there were these basins of volcanic activity that stuck around. As the moon cooled, it shrank, and different parts of it shrank at different times, and that creates earthquakes and some volcanism, and that's what happened with these big basins. They had basically oceans of molten lava that melted in place, that froze in place eventually about 4 billion years ago. So there's So the saturation changes automatically based on what it perceives is the best thing to do. So the colors keep changing. My apologies for that. I'll work out these little details for next time. And we're right on the edge between green and orange. This is kind of surreal. It's like Andy Warhol paints the moon. But here is a mare, big dark splotch. Some of the mares they do think were caused by meteor impacts that were so forceful they cracked through the moon's crust and let some of that magma float up and fill in the space and then freeze in place. I'm going to talk to you about a few different tricks that astronomers use to tell how old the craters are. But before I do that, I'm going to just check that my audio is working. So I'll check on the response to that in a minute. But one trick astronomers use to determine how old craters are is how dark or bright they are. You can see this mare is very dark. And you can see this little crater right here is very bright. Why is this bright and why is this dark? Well, part of the story has to do with what happens when the crater is formed. A huge meteor slams into the crust of the moon and makes a big divot, which is the crater, and also shoots a lot of material out of the moon, out of the crust, and radially outward in every direction. And you can get the faintest traces of some straight lines coming out of this crater here, going off in every direction. And that is called the Ejecta Blanket. That's the stuff that was ejected out of the crater when it was formed. And that stuff gets kicked up with every single meteor impact, and it piles up over time and gets darker and darker. So when the top layer gets formed, it's brighter, but when it piles on top of other older layers, it eventually darkens. Part of the reason the moon is going in and out of focus is because the wind is quite strong tonight, and that disturbs the atmosphere of Earth, which makes the things we're looking at come in and out of focus a little bit. So part of this is not my fault. Darn you, wind! See, the moon doesn't have to worry about wind because there's no atmosphere to worry about. There's no air on the moon. The moon is so small it doesn't have the gravity that it needs to hang on to an atmosphere for very long. There is what's called an exosphere, which is trace elements of gases kind of leaking out over time, but nothing you could breathe. It would be better than the best vacuum we could create in a laboratory on Earth. So if you were walking around on the moon, nobody would be able to hear you scream unless you had a radio transmitter. And a space helmet. Oh, you can hear me. Great. Thanks for tuning in on, checking in about that. Let me take a look around, and if you have questions or if you have things you want to take a look at, then let me know in the chat section, and I will respond as soon as I can. I'm going to take a look over on a different spot. You can see some bright spots and dark spots. Those bright spots are newer craters usually. And then when you have a region of a whole bunch of craters piled on top of each other, that's a good sign that it's a pretty old region of the moon. There's been a lot of time for craters to pile up on top of each other. When the impact happens, sometimes it leaves a little mountain in the middle called the central peak. And some of these you can see have a central peak. That one right there has central peak. This one definitely does. Speaking of craters piling up on top of each other, see if you can find any craters that have craters on top of them in this scene right here. I'll give you a minute to scan. See how many you can find where there's a double crater, where there's a crater on the rim of another crater, or even a triple or quadruple. Oh, the seeing is really not very good tonight, unfortunately. The wind is just too much. Okay, I see one right here. Here's a nice clean crater, and then an even cleaner crater on its edge. So that tells us that this bigger one is definitely older than the one that piled up on top of it. And I bet you found some different ones. Let me point around to a couple others I see. Here's one over here. There's a nice little circle here, interrupted by this little circle here. This one is a big circle, and it's got multiple little circles piled up on top of it. So we can start to piece together the relative age of these craters. Some of these craters have central peaks, like I said, where that's kind of where the magma blooped up in the middle after the crater formed and then froze into place. Sometimes it's a remnant of the meteor itself that's just still sticking out as well. Other craters have filled in with so much dust from other impacts that there's no central peak. It's just filled in with sediment. And so some people like to call these swimming pool craters, because it's, or ice rink craters. You can almost imagine skating around on that smooth surface. But it is not skatable, it's more of a dusty powder. My understanding. For my last trip to the moon, that's what it seemed like to me. Okay, let me see if anybody's got any questions. All right, nothing yet, but if you think of anything, I will address them as I see them. Okay, the terminator is the region where the light from the sun just can't get any further on the moon, and so it's the boundary between the bright side of the moon and dark side of the moon. There's always a bright side and there's always a dark side, but they're not always the same side. So which side is facing the sun is always changing over time on the moon. The dark side is always the opposite of the light. They are not the same side. So some people think the dark side of the moon is a particular side, but it's not. It's always changing. What isn't changing is which side of the moon is facing us on Earth, because the moon is tidally locked. It's always facing the same way towards Earth. And sometimes that side is bright, sometimes that side is dark. When it's bright, we have a full moon. When it's dark, we have a new moon. When it's halfway illuminated, we have a first quarter moon or a third quarter moon. Tonight is a first quarter moon, which is the best time to look at the moon through a telescope, if you ask most people, because you can really see the depth of these structures. Look at this crater here. It's got a nice shadow here. When Galileo first turned his telescope to the moon, one of the first things he noticed was that the moon has a shadowy side and a bright side, but when you look in detail at these craters, the shadowy side of the crater is towards the bright side of the moon. And he made the connection to that's what happens in a valley on Earth. When the sun first hits the valley, it hits the far side of the valley, leaving the near side towards the sun in shadow until the sun rises high enough. So he made a convincing case that the moon has mountains and valleys just like the Earth, which was unheard of at the time. And you can see this big mountain range here. Okay, what else we got? Here's an even deeper crater. You can tell the depth of these craters partly by how deep the shadow goes. Okay. Ooh, this is an interesting one right here. It almost looks like multiple craters, all concentric, or practically concentric. I haven't seen this one before. That's very cool. And here is the edge. This is the terminator where the shadow starts, and then this is the actual edge of the moon up here. So it really extends off in this direction, but we can't see it because it's in shadow. Sometimes they call that the limb. And you can get a glimpse when these craters get into focus. Just, you can almost imagine being there and looking off into the distance and seeing this crater near the horizon. Yeah, it's amazing. Okay, the sky is getting dark enough that we might be able to sneak a peek at some other objects besides just the moon. So let me see if we can do that. I'll leave you with a nice crater group as I go explore the possibility of finding Mars in the telescope. So bear with me. I'm going to step away for a second and look for Mars outside. Okay, Mars is visible to my eye, so it should be visible to the telescope even better. Let's take a look over there. It's going to take me a few minutes to transition. Partly because when I have the camera hooked up, I can't look through the eyepiece. I just have to use the force to find this thing. Orion is nice and high in the sky right now, so if you have a chance to look outside, I highly recommend it. Ooh, an unfortunate thing has occurred. The dome has gotten stuck, but have no fear, folks. We'll get there eventually, I think. Come on, dome, you can do it. I think it can. Okay. The dome gets stuck in one particular spot, and it happens to be the spot where Mars is hanging out right now. So we're going to go all the way around. We'll get there though, don't you worry. It's going to go dark for a second, but I will look to see if there's any questions or comments in there. Well, nothing yet. Okay. The moon is going to be eclipsed, but not by the Earth, just by the dome. If you go outside and look at the moon with your own eyes tonight, you'll notice a couple of stars right nearby, and that's Castor and Pollux. A couple of the brightest, there are a couple of the brighter stars. They're top 20, I think, and they are right next to each other, and they are the brightest stars in the constellation Gemini, the twins. So the moon is in Gemini tonight, if you attend to such things. Okay, we're getting close. Oh, don't go past it, don't go past it. There's no turning back. Okay, didn't go past it, just a little further. Okay. have a chance. Gonna slew over to Mars. Okay. Okay, gonna look around for Mars in the finder. Whoa. I'm okay, everybody. Just almost fell off the ladder. It's a good thing I don't have my camera on. That would have been embarrassing. Okay. This is where using the force comes into play. There's absolutely no way. Oh! I think I saw something. Come on, Mars. Okay, definitely had it for a second there. Apologize for the lack of exciting things on the screen, but this is astronomy getting real. Our telescope is not currently aligned very well, so we just have to do it all by hand. So there's an art to it that our usual telescope guru, Dennis Gutzovich, handles amazingly well. I am still learning the ropes. Oh, there we go. Found it. Okay, now which way do I push the button? Left or right? It seems like I should push it right. I was right. I never know though. Okay. So this is Mars. I know it doesn't look very impressive, but you can tell it's Mars by a couple of different ways. One is that it looks red. And another is that it does not look like a point of light. It looks like a little ball. You can see there's a disk to it. There's some width and height. It looks like a circle filled in, not just a point of light. When you look at a star, the best you can do is, even with our most powerful telescopes, is to see stars as a point of light. That's how far away they are. But Mars is a planet, so it's nearby. So to our eye it looks like a star, but when you zoom with the telescope, it looks like a ball. Sometimes it looks more impressive than others. Right now it happens to be a bit far away, so it's not as big as it was a year ago, or even a few months ago. I think in October I looked at it and it was the best I've ever seen Mars. I could see the ice cap, I could see a dust storm, it looked like a mustache on the surface. But tonight it is a little too far away to be very impressive. But now you can say you've seen Mars through a telescope. At opposition a couple of years ago, it was the closest it's going to be in a long time, and it was glorious. This is the time where I wish I could do like the TV shows do and say, enhance, enhance! But, alas, I cannot enhance. Maybe I can save this picture for later. Save it. Mars, not the moon. Okay. I'm gonna check out if there's any questions. Great. Nothing yet, but if you think of anything, let me know. Alright, I'm gonna try looking for a star. Oh, maybe we can, yeah. So right now in the sky, if you're looking for Mars, you look towards the east in the direction of, no, the west, where the sun was setting. And if you look up from the horizon about 30 or 40 degrees, you can pile your fists on top of each other 4 times from the horizon up to Mars. And that's about where it is. But you'll notice there's another red star right nearby, so it's hard to know which one's which. And so let me show you what the other one looks like. The other one is the star Arcturus. Wait, no, Aldebaran, sorry. Which is part of the constellation Taurus. So I'll try and show you what a star looks like through the telescope. Just take me a minute. Sometimes you just gotta circle around until it comes into view. I can center it in the finder scope. Problem is, it turns out the finder scope isn't exactly centered relative to the main telescope, so it doesn't quite get me there. It gets me close enough to circle around and find it. Tell you what, I'm going to look for a bigger target, which is right nearby, which is just a little bit to the right of both of those stars, and it's called the Pleiades, the 7 sisters. So let me just scooch over there. That'll be an easier target. And I'm going to do a couple other things. I'm going to turn off the lights in the dome to prevent light from leaking into the telescope. And I'm going to bump up the exposure time. And some of these stars should start popping into view. Maybe if I stack the image they'll start stacking on top of each other, and what little light is coming from those stars will start adding up. You can try binning things. Oh, that seems to have done something. Okay, more binning seems better. There we go. It's very pixelated, but you can see that this is a star cluster. There's multiple stars in the same part of the sky. It's called the Seven Sisters because back when they named it, you could see 7 stars with your unaided eye on average. But now, most people can only see 6 due to all the light pollution. But if you look a little closer with binoculars or even a finder scope on a telescope, you can see there's dozens, and if you look with a powerful telescope, you see there's thousands of stars there. So this is a star cluster. I have no option to zoom in or out because the CCD camera just has one zoom setting. So this, you can see the 3 stars hanging out together. I'm going to take a picture. Pleiades. There's lots of E's and I's in there. I think that's the way to spell it. Okay, what else do we got? Let's see if we can find the Orion Nebula. Now bear with me, I can't promise this is going to work out because it's a very dim object and these stars are already tough to see. But if you don't mind coming along with me for the ride, I'm trying to test out the capabilities of this telescope and the camera that we have anyway. Learn how to use it. So here we go. May the force be with us. I'm going to slew over, move the dome over to Orion and look for the Orion Nebula. Orion is one of my favorite constellations, partly because you really can see what it's supposed to look like. It really looks like a person. And it's identifiable by the 3 stars right in a row, which are called Orion's belt. And right below Orion's belt, you can see 3 stars, a little dimmer stars going down, and that is where you look for the Orion Nebula, which is a region of stars that are forming as we speak. Or as I speak, I guess. Okay, I found the Orion Nebula in the finder scope. Whether I can find it in the camera is what remains to be seen. Okay. There's something up there. I'm not sure if that was a remnant from before or if this is seeing what I'm looking at now. Alright. So if I up the exposure time, it'll collect more light from a dim object. Okay, that looks promising. And if I stack the images, it piles them on top of each other, so that adds up over time and fills in. Now this is not a great night to see the Orion Nebula because the moon is nearby, so this is a bit of a risky move, but I like to live dangerously. Okay, let me... There we go! There's the Orion Nebula. Hi-de-ho! Wow. That's so cool. So this is a big cloud of gas and dust. Mostly hydrogen, a little bit of helium, maybe some carbon. Probably not too much though. I'm going to take a picture. This is the first time I've seen the Orion Nebula through my own camera. This is so cool. Thanks for coming along on the journey with me. Now this looks like Pac-Man here eating up the nebula, but that is a remnant of the exposure time and the binning. It's really a set of 4 stars called the trapezium that they're shaped like a trapezoid. This is one so bright that it's washing out everything else. Okay, so if I turn up the binning, I can see the cloud more. This is a star-forming region where many, many new stars are being born. It's a stellar nursery, you could say. And these 4 stars, the trapezium, are new stars that are shining so bright they're actually responsible for most of the energy illuminating this molecular cloud. Kind of like car headlights in the rain. You can see the raindrops around the car headlights, or in the fog, you can see the fog illuminated by the car headlights. That's what's going on with these stars in this gas cloud. Now I'll try to turn the binning down and the exposure time down so you can see the trapezium stars individually. Whoops. Forgive me as I just experiment a little bit. And how about stacking these images? It's actually a 5th star, and but it's hard to catch with your eye. And also, each of these stars in the trapezium are not just single stars, they're actually double or triple stars all going around each other. And in fact, most stars, or at least around half of the stars that exist, come in pairs at least, if not more. There's very few, when we look at it, there's relatively few single stars like our sun. Most of them are double stars, like the one in Star Wars. Okay, the Orion Nebula, that's so cool. Alright, what else can we see? We could take a look at the stars in the Big Dipper. It is 8 o'clock, so it's getting a little late. So if you need to go do something else, don't feel pressure to keep watching it live. But I'm going to just keep going because it's such a nice treat to get up here and do this. And I don't know when it will happen again. Hopefully soon, but with weather and pandemics, you never know what's going to go on. All right. I'll see if I can turn the telescope, the dome, over to the Big Dipper. What I'll do is point back to the moon first, because that is easier target, and then I can move the dome around to see that. Okay, got the moon in my sights, and we're inside the moon. Well, I gotta bump the exposure time way down. There we go. Now we can start to see the moon again. Oh, it's a little out of focus. Maybe that's why those stars weren't exactly separable. Tweak the focus a little bit. It's so windy, it's hard to get a stable focus. All right, this is that interesting crater group we were looking at last, looking at the moon. Okay, let me slow down. Just panel. Ah! I lost the moon. There you are. Oh gosh. You can really see the contrast of the bright young craters and the dark older ones. So cool. Ooh, there's a cool structure right there. Check this thing out. It might just be a remnant of this crater here. It looks like this region is lower than this region. Sometimes there are faults that form as the moon continues to cool and crumble. You'll get a straight line feature, but this might not be one of those. Here's a nice one with a central peak. Ooh, now that's the crater group right there. You can see this one. You can just barely make out the central peak. That's illuminated. It's rising out of the shadow. There's this one, this one. Very cool. I'm going to take a picture of that. Okay. Maybe I'll just knock look at a couple other things on the moon, then we'll head over to the Big Dipper. And I'll just go show you a double star. Okay, I'm going to take a picture of this one. This is better color. There's a nice one with a crater on the rim. Okay, on to the Big Dipper. We might lose sight of the moon as we turn the dome, but the moon is so high that it might come back into view. By the way, the Big Dipper is your ticket to find the North Star. The North Star is not in the Big Dipper, but you can use the Big Dipper to find it. So, the Big Dipper is also one of those constellations that really looks like what it is. Of course, if I'm being technical, the Big Dipper is not the constellation. The constellation is Ursa Major, which meant to represent a bear, a big bear. But the asterism, the thing that people recognize, is the Big Dipper. And that looks like what it sounds like. It looks like a big spoon. Well, there's something going right behind the Big Dipper right now. Is it a satellite? Well, let's see if I can find it. Going the wrong way. There. In the view. Just went out of the frame. Okay. Sorry, just concentrating on finding the stars, but I just saw something fly by the star I was looking at. I'm looking at the star Mizar, which is not the end of the handle of the Big Dipper, but the next one in. And hopefully we'll see that it is a double star. Double stars are more technically called binary stars. Ooh. There we go. Ah! Lost it. I got too greedy. There we go. Alright, I'm going to keep it there, and I'm going to try and mess around with the binning and the exposure time, see if we can separate these two stars. Now, Mizar is a double star. There's things called visual binaries, which is when two stars look like they go together because they happen to be in the same direction of the sky. And then there's binary stars that actually orbit around each other. And Mizar is both. Both has a visual pair, and if you look closely enough, it has a star, that companion star, that they go around each other. And at least I'm able to separate these two. This software is making a liar out of me. I told you that Mars is a disk and that stars look like point objects. So why do these look like disks and not point objects? It's because they're exposing so much of the camera that it actually is taking up a lot more pixels than it really does. So if you saw this with your eye in the telescope, they would look like really points of light. There we go. Can't bin any less than one. Okay, so there you can see 2 points of light. This is Mizar, the binary star in the Big Dipper. So I can't zoom out enough to show you the Big Dipper, but this is the second star on the handle. Alright folks, I think that's going to do it for this edition of the live stream from Collins Observatory, Salem State University. I'm Luke Conlon. I'm assistant professor of physics in the chemistry and physics department. So stay tuned for future live streams and new astronomical objects to check out. Thanks for tuning in, and some of you I'll see you in class next week. Thanks everybody. I'm gonna sign off.